I used to study science in university, and I decided to leave the academic degree because of several reasons. But something that I realized, especially in hindsight of looking back at my time as a science girl, there are so many beautiful lessons outside of the scientific knowledge that I got to learn and experience through the degree. And I just wanted to share it because I feel like science teaches us so much between the lines, and sometimes we don't even realize it. The first point I really want to talk about is curiosity as a central driving force. I feel like curiosity is an emotion that we all underestimate so much. We think about all of the in between and the logistics instead of just following that curiosity. In science, you kind of don't really stop your curiosity all too much. I feel like once you have a clue, once you have a lead, you follow it. And if you kind of drift off of that part a little bit because you have found another question that you want to investigate, you follow that one. And instead of treating everything like a linear journey, you treat it as a journey that resembles a mind map much better because science is quite aware of the fact that everything is just interconnected, every discipline, every function, every question. The second point I already mentioned, and that is the interconnectivity of disciplines. I used to be an applied biology student, and my first year was actually not filled with biology subjects or classes, but with chemistry, physics, and even computer science. STEM isn't just called STEM because it's similar, but because it's genuinely interconnected. That is one of the things that has always confused me about school, because subjects were almost treated as if they were separate islands, as if there was no connection between all of the subjects. I feel like that is a thing that I only started learning outside of school, that everything is very much interconnected, and science definitely played a big part of it because teaching, being taught science, always showed you so clearly just where the bridges were between the disciplines. My third point, I feel like I should elaborate a little further, so I'll name it first, and that is scientific writing as a blueprint for structural thinking. Why I'm calling it a blueprint for structural thinking is because scientific writing, so the structure of, for example, lab reports, very much resemble multiple perspectives to approaching an idea, to approaching a question and a problem. And if you're not familiar with scientific writing, it basically starts with an introduction that gives you the crucial background knowledge, or at least a portion of the background knowledge, the immediate background knowledge that you need in order to understand a paper. You will then dive into the materials and methods, so the approach used to debunk a question. And then you would go into the results, or actually the calculations and then the results. You would just talk about the results with no discussion yet. And then in the discussion, you would approach even problems, limitations, and similar. Also, things that went wrong during your procedure. And then you would have the conclusion and where you would think about the further steps of how to continue said research, why it is important, and so on and so forth. And I really love this approach because one part that we oftentimes forget about not just science but thinking is that the world is a very complex place and everything we do has limitations. We oftentimes just try to ignore said limitations because it gives us stability. It gives us comfort to feel like we have the answer to everything, even when that is realistically not possible to have that one answer for everything. It's usually a more multi perspective approach. And what I also love about scientific papers is the conclusion part, where you basically dive into further steps and also the foundation, the motivation of why you even did the research to begin with. And that is a very beautiful way to approach the continuation of things. Again, it resembles very much this mind map of this is not just an island, this is not just one singular question that I have finished answering, because there is no finish line actually. It just continues. Another thing that biology taught me was teamwork and social skills, especially in regards to the laboratory. In the lab, even when you do singular work, you're basically contributing to the whole process, kind of like a puzzle piece. I feel like in the lab, I was more aware of that puzzle than I was in previous group projects that we did in school and stuff, because you were contributing one portion of the perspective, usually. You also learned how to communicate with multiple different kinds of people, how to differentiate your workflow from someone else's, how to adapt different workflows to create a full picture, and also to organize writing the paper together at the end of a lab. And this whole coordination taught me a lot of social skills and a very new perspective to teamwork, because sometimes it even happened in the lab that you were put together with friends into a lab group and you were super excited at first. You had a great time together, but you realized that, sometimes even my friends are not necessarily people that whose workflow aligns with mine. And that is okay too. You can differentiate the process from the people. One of my favorite points are coming up now, and that is trial, error, and embracing mistakes. One of the first things I remember my professor saying during the first lecture was when someone asked them a question about a process and they initially asked something quite simple. It was just, why does it happen? And our professor looked at the student and she said, but we don't know yet. And you don't even know how mind blowing that was to me when I was sitting in that lecture and you have someone standing in front of you who is a professor with one or two doctor titles, and you just sit there and they admit out loud, we don't know. It was such a new phenomenon to me because in school everything was treated as absolute, or at least my teachers treated information as if it was absolute. And getting this perspective of, hey, we indeed do not know everything, we're still in a process of finding out, makes me extremely curious and extremely hopeful too. Because again, it plays into this whole perspective of life is complex, and there are so many different perspectives that we can take, that we can explore, and that in and of itself makes it very exciting. Same thing during lab work. I was very fortunate to have supportive tutors and professors who, even when you made a mistake, they did not approach it from a place of, oh, you did a mistake, you're terrible for making a mistake, but they treated it as a part of the process. And I think you can even see that in scientific calculations. Something that you always include are deviations. You always do the deviation calculations. I swear that formula looked so scary when I first looked at it, and then after a while, it really just became a routine to include it. But to know, hey, this is a snapshot of a result. It is a snapshot of the truth, but it's not the entire truth. It's a very encouraging message. Also, to continue developing your own skills, your ideas, your research. And it really helped me gain a healthier grasp on my perfectionism. And the sixth point that I have here is again regarding limits and the transparency of the limits. Something I've heard before, I'm not sure if it was from my professor or from another source, but someone once said you can recognize a good paper based on how transparent they are about the limitations. Because again, life is complex. We're not yet at the point where we have tackled most of the perspectives to a question. So we just simply don't know oftentimes. Same thing also, research and logistics oftentimes already just give you limitations in the logistic regard. And therefore, what we often work with are models. And that oftentimes leaves out a lot of variables that are part of life, but not necessarily part of the lab, in order to research one aspect as accurately as possible. I think that's a very valuable thing that I've learned from science. This whole to not be afraid of saying that you don't know, because that is reality. A lot of times, and I feel like that's a trap that is happening a lot today, and that is also where a lot of pseudoscience starts to build, is in the crevices of partially true things that just get exaggerated to absoluteness. Point seven that I have is my appreciation for scientific linguistics and the precision of it, more importantly. If you were ever curious about why bacteria, plants, and other organisms are called the way they are in Latin, it's because there's a system behind it. You can look it up. It's a whole thing. We learned about it in microbiology back then, and it was at first you were just like, why can't you just call it X? And after a while you understand why they call it YZ, and you're like, oh, okay, I actually understand this organism better simply because of the systematics of the name. And you see that too with, for example, chemical components. And I think it's very valuable because once you understand the system, you can retrieve information via this one name quite easily. But you can also connect the words that are used, the associations that are used in the name with other things. So even when you encounter something unknown, you can look at the name and you can probably already get some first ideas about what it is about. And I feel like that really helped me with my approach to unknown things, because you do sometimes know what it is. Maybe not exactly, but association thinking. And that is also a very valuable first step for learning, because it allows your brain to make connections. And the last point that I have here today is that science taught me questioning as a skill. Sometimes asking good questions is more valuable than doing clean pipetting, because that is the start and the continuation of your work. It helps you understand things better, it helps you find new paths, and that is essentially what helps you broaden your horizon. So, no, I don't think there are any stupid questions. There may be repetitive questions, there may be annoying questions, yes, but there are no stupid questions, because anything that broadens a horizon was not unnecessary. I would say these 8 points pretty much give a solid mind map of what I was able to learn during my science studies, even if I didn't finish the degree. It was a very valuable time that I still carry very close to my heart, and I hope these points give you a new perspective too. So thank you for listening, and I'll see you in the next episode. The end.